Today I'm back with some Linux and open source news. We're going to be getting right into it as there is a lot to cover. First, we're going to talk about Fedora 43. It's officially out now and available for download. I'm going to post a link in the description below so you can download it direct in case you're ready to upgrade. There's quite a lot of accepted system-wide changes. Fedora 43 was aiming to release about a week ago on October 21st, but it was delayed a week as there were outstanding blocker bugs and insufficient testing coverage in order to give it a clear release status. Well, now, some of the biggest deals that we have coming with this change is they're going to raise the default boot partition size from 1 gig to 2 gigs. This means that the boot partition is now doubling in size, and this is mainly because of 1 gigabyte is becoming a little bit too tight as the kernel and init RAM file system sizes keep growing. This means that newer kernels include more built-in drivers and features, and the compressed image, which is the init RAM file system, which helps set up your root file system, includes more modules and firmware. So mainly this is a preventative change as the boot partition gets bigger and bigger. This allows for more headroom for our startup firmware in order to boot the disk. It's an interesting change as not long ago we doubled the size from 512 megabytes to a gig, and now we're doubling again. The other big change is that there's no more GNOME X11 on the Workstation Edition. With 43, we dropped that for Wayland only mode. So that can be a significant change if you were used to using X11 as your default Windows server. Either way, the image is now available for you. Under Workstation, you have the 43 release. If that's what you're using, of course, there's different images all across the board. In other news, Ubuntu is struggling a little bit as the official Ubuntu flavor that receives Canonical's old Unity desktop is in serious trouble. A couple maintainers have stepped back due to personal time constraints, leaving no active developers maintaining or fixing the Unity desktop environment or Ubuntu's integration of it. Because of this, Ubuntu Unity 25.10 was not released due to unfixed bugs. The project currently has no one with technical ability to repair or maintain it, and they're making a public statement calling for new volunteer developers to step in and keep the flavor alive. This means Ubuntu Unity could die off entirely by Ubuntu 26.04 if people do not step up. And the statement from Mike here, I'll be honest and open with you, our project lead and I have been absent for a long time. I left around 24.10 release. In my case, it was because of personal and private matter that I left for a longer period. Don't worry, all is going excellent now, and I recently returned to jump in and help out. I can't speak for Rudra, but all I know is that he has less and less time around 25.04 release because of the exams going into university. This is still the case, and no matter what, more important than anything else, something I deeply respect, and we cannot blame him for that. With me gone for a longer period and Rudra not having time, sadly resulted in bugs not getting fixed and things not getting tested properly or at all for my point of view. If I'm not mistaken, the ISOs are being automatically generated and tested with no human interaction, which is a big deal. In short, it got worse. Unity is broken and needs to be fixed, and they're calling for people to try and join the team. We'll follow up what's happening as Ubuntu Unity's future is uncertain at the moment. It needs new developers soon. If you're interested, I'll put a link in the description below to this discourse so you can discuss what it would take to join the team. Anyways, interesting news from Ubuntu. And moving on to desktop environments, this week we have KDE Plasma 6.5 being dropped, including some new features in 6.6. For users of KDE Plasma 6.5, we have UI improvements, including various UI changes, but what's more interesting is what's coming out in Plasma 6.6 at this point. You can now find About the System page by searching for WinVersion, or WinVer, which is familiar to Windows refugees, as they say here. So about 2 weeks ago, Windows announced Windows 10 end of life, which we're now a couple weeks into, which is a big deal as people have been going to other operating systems because of this. And you can tell KDE is trying to make the transition a little more familiar, although I think there are better options to use than the KDE desktop when it comes to Windows users. But if you're accustomed to Linux and Plasma, this is really not going to make a change, but it's interesting as WinVer is now being aliased in a small way. For users migrating over from Windows, this familiar command reduces the friction of being able to see your system information at a quick glance. The most notable bug fixes here, some regressions in the KWin crash, also fixed a case where Plasma could crash when hot plugging screens, and 6.5 includes some highly requested features, including rounded bottom window corners. Don't worry, you can change yours as well. Another one is automatic light to dark theme switching based on the time of day. There's also a pinned clipboard items feature, which allows you to save text and use it regularly into the clipboard. And for artists out there, you can now configure any rotary dials and touch rings on your drawing tablet using System Settings Drawing Tablet page. And one of the interesting things in performance, We've added the support of overlay planes, which promises to reduce CPU usage and power draw when displaying full screen content using compatible GPUs. So that's an interesting development, as with optimizing the splash screen code, they're calling for a reduced time and duration of the login animation, helps the desktop load faster, and makes for a snappier overall Plasma experience. Those of you using KDE Plasma, it's quite an improvement at 6.5. You might want to check it out. I'll post a link in the description below so you can check out the full list of changes. But moving on to a new patch that's called Add Initial Clang Build Support. This latest patch set series adds initial support to build Glibc with Clang, extending the work to build the test cases with Clang initially done by H.J. Liu and Adhem Erval. So why is this so interesting? It's a major foundational patch set for the GNU C library and the broader Linux toolchain ecosystem. Until now, Glibc, the core C runtime library used by nearly all Linux systems, could only be built with GCC because it was dependent on the GNU-specific compiler, behavior, and inline assembly syntax. With this patch set, this makes Glibc itself compatible with Clang 18 Plus on x86 64 architecture or AArch64, and it supports key configure flags, including these here, like enable stack protector, enable profile, enable fortify source, enable CET, and enable memory tagging. It still uses the GCC runtime for now, but future work will remove towards Clang's compile RT. Why is this important? Well, Glibc has been deeply tied to GCC for decades, and allowing Clang to build decouples Linux's core runtime from a single compiler vendor, and it lays the groundwork for pure LLVM Linux distributions. This means in the future we could self-host Linux with LLVM only and be able to compile the entire userland with Clang, including Glibc, the kernel, and applications. It's definitely an interesting move and a pretty cool patch set to see as we modernize Linux compilation. And now I want to talk a little bit about FreeBSD, but before we do, make sure to subscribe below and smash that like button on the way back up. As we move on from Linux, FreeBSD now builds reproducibly and without root privilege. Just announced, this milestone eliminates the need for root access during ISO, virtual machine, and cloud image creation, and adds full reproducibility across the release pipeline, meaning every build from the same source produces a bit-for-bit identical binary. This is very important to FreeBSD. When it comes to security, there's no more root in the build pipeline, meaning removing root from the build pipeline closes a major attack vector. Now even the official released infrastructure can build in a sandboxed or containerized environment without having any privilege escalations. This is a huge win for security. It also helps you verify trust with timestamps, file ordering, and environmental variables normalized now. Two FreeBSD builds from the same source are now producing identical binaries. This allows for public verification to make sure that releases are not tampered with, easy auditing and debugging, and it helps for stronger compilance when governments and critical industries want to adopt FreeBSD. A very cool and major modernization effort from FreeBSD. FreeBSD 15 will be one of the first general-purpose Unix-like operating systems that's entirely buildable, verifiable, and reproducible without root. Now I want to talk about Turbosqueeze. Turbosqueeze is a real-time multi-thread compression library written completely in C and C++. This new open-source MIT-licensed real-time multi-thread compression library targets the same use cases as ZSTD, LZ4, and Snappy, but with modern parallelism and async job scheduling. It achieves very high compression speeds with single threads, and it's currently benchmarking faster than ZSTD3 at low levels, but provides lower compression ratios. So why use Turbosqueeze? They claim blazing fast performance, seamless user integration, energy efficient and green computing, scalable and flexible. Features include real-time multi-threaded compression and decompression, file and memory buffer support, asynchronous job scheduling with progress and completion callbacks, highly configurable compression levels and format extensions, MIT license for maximum freedom. And some benchmarks for single-threaded performance. We have different types of compression libraries being used, and a standard memcopy is what the control is here, meaning no compression at all, 100% here, and at what rate the system can do that. So a memcopy can be done at basically almost 13 gigs per second. And then we go down to look at Turbosqueeze in comparison to the rest of these. So 305 puts it in the top 3 for compression in megabytes per second, only to come third to LZ4 and Lizard. Then we have 2503 coming in second when it comes to LZ4. And in comparison, it reduces things down to 62% of the original size. So what does this mean for people trying to use this compression library? Turbosqueeze now will provide a strong balance between throughput and decompression speeds. It achieves competitive compression through 305 megabytes per second and a very high decompression speed of 2,503 megabytes per second on dataset. For scenarios where minimal storage size is top priority, higher compression settings of ZSTD or higher compression algorithms are preferable. For real-time streaming, Turbosqueeze and LZ4 family compressors offer excellent trade-offs. This is for a fair and square comparison of Turbosqueeze versus other fast, lossless compressors in a single-threaded performance mode, but the point of Turbosqueeze is the multi-threaded compression and decompression. The multi-threaded benchmark using as a test file, it achieves 1,813 megabytes per second compression and 5,818 megabytes per second decompression speed, which is quite fascinating as this new challenger to ZSTD and LZ4 offers fast and efficient compression at a much faster decompression rate. This helps us save time in real-time telemetry streams, game engines and emulators, and in-memory caching layers like in Redis-like systems. This new Turbosqueeze library is reflecting a new wave of C and C++ software, which is focused on fully multi-threading by design, async real-time capabilities, and open source use with an MIT license that's open and commercial friendly. It'll be interesting to follow this along, and if you're ready to level up your Linux experience today, check out my checklist, cheat sheet, and mind map, all available at SavvyNik.com. There's more news to be seen. As FFmpeg has now added Vulkan accelerated decoding for Apple ProRes. This is Apple's high-quality professional video codec. The new feature uses custom Vulkan shaders to support all major ProRes profiles up to quadruple 4xq and including 422 and 444 chroma subsampling, 10 and 12-bit component depth, interlacing, and alpha channel support. This is very interesting as FFmpeg is now introducing GPU-accelerated ProRes for everyone. This means the decoding, which has historically been dependent on Apple's proprietary frameworks, is now no longer, as FFmpeg brings cross-vendor GPU acceleration for ProRes. This includes Linux and BSD users, Windows systems without Apple frameworks, and embedded in cloud GPU environments. It's very interesting to see as this brings pro-grade real-time ProRes decoding to any system with Vulkan, and it will help projects like open source video editors with Apple's wall-gardened video codec. We do receive some benchmarks for 4K, and it'll be interesting to follow these developments along. Moving on to file systems, I talked about this in a previous video where I go more in depth about EXT supporting now larger block sizes in memory pages. And with the large block size support, or also known as LBS, EXT4 can now use block sizes like 64 KB on systems with 4 KB memory pages. This essentially improves writes up to 50% in some benchmarks versus the older big allocation feature, and it passes the XFS tests without regressions and integrates cleanly with existing large folio infrastructure in the kernel's virtual file system and memory subsystems. This is awesome as it is a major effort to bring EXT4 up to speed with other Linux file systems. At this point, EXT4 is the most widely deployed and used Linux file system and has been historically tied to the Linux kernel's page sizes, which are typically 4 kilobytes. Breaking this limitation helps handle bigger I/O chunks per operation, reduces metadata overhead and page management costs, and brings EXT4 to feature parity with next generation file systems including XFS and ButterFS. This definitely helps EXT4 for high performance NVMe, large SSDs, and future storage workloads. And again, a significant 50% faster write with LBS versus big allocation is a big deal for things like databases and datasets, video storage, any large block sequential writes, anything between 32 and 64 KB, and in systems that stream or record high bandwidth data. There's definitely some awesome benchmarks to cover, but I cover this in a different video and I go way more in depth about what this actually means for Linux and the EXT4 file system. I'm going to put a link in the description below if you want to check that out as well. Just know that this patch series is being added in officially to make EXT4 even better when it comes to multi-gigabyte workloads. In other news, Nvidia has begun posting open source driver packages for the next generation quote-unquote Rubin GPUs. This patch series here updates driver hardware detection logic, replacing old NVPMC boot 0, which is a register through Blackwell, with a new NVPMC boot 42 identifier used by upcoming architectures. This change ensures Noah can recognize Turing through future GPUs without further modification. Traditionally, Nvidia has been closed source and guarded itself against the Linux kernel making drivers for it. But now with Nova, which is a graphics driver developed directly from Nvidia and is written largely in Rust, available as open source, the company is now officially developing upstream and transparently, as we're seeing here. This patch here confirms that Nova is probably the future when it comes to Nvidia drivers. It doesn't seem to be an experiment, as they've been maintaining it for a while now. Nvidia's long-term Linux kernel driver architecture seems to be supported completely by Nova and will continue that way. It also marks the significance of Rust in software development, one of the big first real industrial deployments of Rust inside the Linux graphical stack, and it's not an academic demo at this point. The Nova graphics driver is a production-oriented driver backed by Nvidia. It's interesting to see this project and how it's growing. All in all, Nvidia is not only developing the next-gen GPU drivers in open source, but also will be getting future hints as to what Nvidia is doing behind closed doors based on these patches, so it's very interesting to see them developing the next-gen GPU drivers. Servo, the modern open source web browser engine written in Rust, originally created by Mozilla and now maintained by the Linux Foundation in Europe, has seen some major updates in the last week. Servo's demo browser, Servo Shell, just added an experimental mode button, which now one-click toggles on the latest and greatest unfinished web platform features, much like Chrome flags can do. And in the performance category, Servo currently runs single process mode unless you opt into multi-process mode. And we've landed a few performance improvements in that default mode. For one, the single process mode script can now communicate with the embedder directly for reduced latency. We also create one thread pool for the image cache now, rather than one pool per origin, which all makes for faster message passing, lower memory usage, and smaller binaries. There also have been some new web APIs added, embedding improvements, automation fixes, including high DPI scaling, and smarter string handling. Servo is an important project because it's a true independent alternative to Chromium. Servo is one of the only remaining independent browser engines not based on Chromium or WebKit, and it is an important project as it helps diversify the web ecosystem, avoiding single vendor lock-in through Google. Hopefully the dev continues on with Servo. I know a lot of you like following along with this, so I make sure to try to cover Servo every once in a while when they reach a milestone. Now with some breakage in Ubuntu 25.10. Unintended upgrades was broken in 25.10 due to Rust's core utilities date bug. This all happened after a recent transition from using the C-based core utilities in Ubuntu to the Rust-based core utilities, which were released in 25.10, and it had caused some major issues for Ubuntu. One being unintended updates being completely broken. So for those of you unaware, unintended upgrades is the automatic security updates which were broken, specifically because of how Rust's implementation of the core utilities used date and how it handled timestamps. This bug made Ubuntu think the system upgrade timestamps never aged, so unintended upgrades never triggered, ultimately leaving systems stuck without automatic security patches. A fix for this has already been tested, and users must manually run apt update and apt upgrade to get the fix. We can definitely expect some early fallout from Rust core utilities migration over from the GNU core utilities, the C-based ones. This is the first high-profile regression from the migration, at least that I'm aware of, that shows you some compatibility gaps between Rust and GNU versions, but it definitely shows you how small differences in low-level utilities can cascade into major breakages. It is good that Ubuntu is experimenting with 25.10. Of course, they wouldn't do this with their long-term support edition. This is basically a trial run to see if they're going to use it in the long-term support edition, and is quite a big experiment because this can affect a lot of users and needs to be tested well before we get the long-term support candidate in 2026 of April. Ubuntu's Rust-based core utilities is definitely going to have some growing pains. We'll see how this key transition of the entire open source core utilities goes. I'm going to be watching this closely. This is just the first of, I'm sure, many other issues. It's definitely not the first issue, just nothing as major so far with this migration. Anyways, let's continue on to talking about the core utilities specifically in Rust. As they received a update to the 0.3 release, we're happy to announce the release of core utilities 0.3, which highlights some performance improvements in comparison to the GNU C core utilities. So a claim here is a few of the utilities have gotten faster, a 1.2 times increase in base 64. Expand has a 1.8 times factor increase. Unexpand is 1.5 times faster. NL is 1.57 times faster. Sort, they claim, is 3.72 times faster for regular sorting and 1.46 times faster for numeric sorting. Fold is 1.19 times faster through optimizations, and unique-C is 1.13 times faster. Quite interesting, as another important metric is what does the total GNU test compatibility suite look like when it comes to Rust versus C. This just shows you how many pass and fails we get in comparison to the total number of utilities that are used in the GNU C-based library versus Rust. And what's happened this time is we get a larger failure. Basically, there have been 6 tools that have been changed from passing to failing. They're skipping 6 of them, so that's really the big change there. So they've lost some percentage of the tools. They were passing 87% of the total utilities when comparison to the GNU core utilities. Now they're only passing 80, we'll call it 4%. That's a 3% decrease from 0.2 to 0.3. Anyways, about 0.83% are being skipped. Failure rate has gone up 2.31%. And right now, we're totaling 16 new tests for tools when comparison to 0.2, meaning they went from 618 utilities to 634, which all in all, pretty good. Can't expect much there, as they're slowly reaching one-for-one compatibility with the GNU core utilities. We'll see how it goes, as the first Linux distribution, Ubuntu, has officially taken the Rust core utilities. Will others follow? It'll be interesting to see and follow along with all that. And I want to end on a critical vulnerability. CVE 2025-62518, dubbed Tarmeggedon, was discovered in the Rust async tar library and its forks. This vulnerability allowed for remote code execution, also known as RCE, by tricking the tar extraction code into writing or overwriting arbitrary files when parsing through malformed nested tar archives. This logic flaw was not a memory safety issue, but the parser mishandled headers, which caused misaligning internal read positions and treating hidden data as valid archive entries. So with Tarmeggedon here, why this matters, especially for Rust, as after we just got done talking about some tools, is that Rust is not bug-free and vulnerability-free. As this wasn't a memory corruption error, it was a logic error, and shows how developers can still introduce exploitable flaws by just writing code. And it highlights a big issue with Rust, as abandonware is becoming a problem in Rust's ecosystem. The most popular effective crate was Tok.io tar, which has 5 million downloads and effectively abandoned. No maintainer, no security updates, and highlights some of the modern ecosystem flaws when it comes to Rust, including dependency, abandonment, and fragmentation, which can create multiple security risks and lead to supply chain attacks on various different build systems. The incident overall underlined how even low-level utility crates can become a high-impact attack vector and create multiple vulnerabilities, especially when it comes to archiving. It's a bit of a wake-up call. While Rust tries to guarantee safety, unmaintained crates and logic flaws remain serious threats, and puts into question whether or not some of these Rust crates and libraries should be replacing their C and C++ based counterparts, which have remained stable over decades, versus the Rust ones that are new and modern and may get abandoned. It really puts in some weight on whether or not moving things to Rust makes sense if it's going to introduce vulnerabilities like this by simply getting abandoned. This blog from Fedora is highly technical, and it goes in depth on what actually happened. I'm going to post a link in the description below. Check it out if you're interested. Let me know what you think about all the news in Linux and open source this week. Don't forget to subscribe below to follow more news like this. Also, smash that like button on the way back up. Catch me in a great community on Discord, and I'll catch you in another video. Thanks for watching.